Hi everyone, welcome to today's video. As you can see, it's on nonlinear relationships. So I'm just going to go through this summary. I don't have a lesson series for this topic. These are the outcomes. So you might like to pause the video and just read through what's on the screen. So the first learning intention is to graph simple nonlinear relations with and without the use of digital technologies. So I would like you to be able to do this with a table of values and also using something like GeoGebra. See with example 1, complete a table of values for the relationship below and draw the graph. So we've got y equals x squared. The table of values is here. So for the x values, I'm going to use -2, -1, 0, 1, and 2. And you'll notice that I've got the negative numbers in brackets. That's because when we square negatives, we get a positive number. The mistake tends to be that people put this down as -4, when it is actually 4. So you can see with the calculator, if I go -2 squared equals, I get -4, but we actually need to put brackets around it. So we get +4. So that tends to be the mistake that people make. So put these in brackets so that you don't make that mistake. So -2 minus is this point here. So we go across -2 and up to 4. So that this point here corresponds to here. -1, 1, across -1, up 1, goes there. 0, 0 is here. 1, 1, across 1, up 1, and 2, 4, across to +2, up to 4, and then we draw a curve in between the dots, which actually gives us a parabola. So you might like to pronounce it as parabola or a parabola. So we do need to be able to use the table of values to graph simple nonlinear relationships. And I'll go through how to do it in GeoGebra as well. Before I do, you can see here there's a picture of this basketballer shooting the ball, trying to get it into this hoop. I actually took this photo and I can tell you that he did make it. So with GeoGebra, we can move the parabola around until it actually matches up to the formula. And that's what mathematicians tend to do. So if I start with a new one, of y equals x squared, and you can see down here the buttons that I've pressed. This is the parabola that we get. So y equals x squared, you can see up in the top left hand corner. So we want to use GeoGebra to do other ones as well. So y equals x squared plus 2. And you can see that it moves 2 up 2 this way. So adding 2 onto the parabola, moves it up to. So you should ask yourself what happens if we go -2 or -3. It actually moves the whole parabola down 3. And you can see here the table of values. So -2 squared is 4, plus 2 is 6. And -2, 6 would be up here. So 0, 2 is easy to see. So 0, 2 is this point. So that's what I want you to do in GeoGebra. You can see here, this is what the syllabus wants us to do. These examples using digital technologies. So the next one that I've got is y equals 2x. So this means 2 to the power of -2. So this time it's not squared, it's 2 to the power of. So we use this button. -2. It's good practice to put negatives in brackets. So we get 1/4, which is 0.25. If we scroll back and change it to -1, you can see that we get 1/2, which is 0.5. So exponentials look like this. So parabolas, you should think basketballs, especially upside down ones, which we'll get to. Exponentials, you can think of things like compound interest or bacteria. So what this means is when we go from 1 to 4, you can see this graph is actually doubling every time. So the 0.01 is here. 1, 2, so 1 gets doubled. And then the next point, 2 gets doubled. So our next point would be 8. So this curve has exponential growth. So you might have heard of that before. So example 2, you can use GeoGebra or Desmos to graph these relationships. So that's what I want you to do. Just make sure that you can do these. And you can see the red one, y equals -x squared, goes like this. So that's the one that looks like a basketball shot. So there's more exponentials here. 2 to the power of x doubles, 3 to the power of x triples, 4 to the power of x multiplied by 4. They all go through this point because anything to the power of 0 equals 1. Circles, so this pink circle has this equation, x squared plus y squared equals 1. So you can see here the radius is 1. X squared plus y squared equals 4 has a radius of 2. So we're thinking x squared plus y squared equals r squared, the radius squared. Again, these are the functions that you could draw. We call them functions. We also call them nonlinear relationships. Nonlinear because they don't form. Okay, good luck. Let me know if you get stuck.